Good morning, this is your Stat Sensei, Mr. Spensei, and this is the pre-quiz, and this is the confidence interval for Mr. Spencer's Happy Juice. So Mr. Spencer's statistics class noticed that Mr. Spencer appeared grumpier and more tired than usual, and that he was assigning copious amount of statistics homework. The students know that Mr. Spencer enjoys one or more cans of Happy Juice every day. The Happy Juice distributor claims that each Happy Juice container contains 12 ounces of delicious Happy Juice. All right, so we have a claim here. So that sounds like that's probably our mean. Sounds like our mean here is going to be 12 ounces. Which are normally distributed. Super important. Mr. Spencer's students collected a random sample, all right, of Happy Juice containers from a batch of over 1,000. So we have a population of size of 1,000, and weighed the amount of Happy Juice to determine whether or not the distributor was putting less than 12 ounces. So this right here sounds like my alternative hypothesis if we were running a hypothesis test. Construct a 95% confidence interval and explain the meaning of the confidence level. All right, so if we're constructing a confidence interval, we're going to need the formula T equals X bar, or X bar plus or minus T star S divided by the square root of N. Well, we're going to jump down and do our inverse T because it said 95%. So let's go ahead and calculate our 95% interval. And here's what we did. We went second vars. Oops, let me slide that up. Second vars, inverse T, parenthesis 1 minus 0.95. That's the confidence level divided by 2. And our degrees of freedom happens to be, well, we have a sample size of 20. So 20 minus 1. Please remember this part right here is our DF, our degrees of freedom. Right? You don't need to label it, just don't want you to forget about it. All right, so when I do that, I end up getting 2.0930. Please make it positive. All right. Well, we need to enter all this data into stat edit, which I've already done. So if I go to stat edit, there it is. There's my list of data. And I can go stat calc 1var stats. And I end up getting an X bar of 11.89, a standard deviation of 0.1713. There's my sample size. So I can go ahead and figure out what my label is. So 11.89 ounces. All right. There's my standard deviation. And because we're using the sample standard deviation, this makes it a T distribution. Our sample size is 20. Our degrees of freedom are 20 minus 1, or N minus 1, which equals 19 in our case. All right, drawing it. Hypothesis tests are centered on the population mean. However, confidence intervals are centered on X bar. So in this case, we're centered on our X bar, and our X bar is 11.89 ounces. So that's what we're centered on. And basically 95% is here. And we're going to calculate a lower and upper bound in just a moment. Next thing we need to do is we need to plug in. Well, we're going to plug in 11.89 for the X bar. The T star comes from right here. There's our sample standard deviation that's being plugged in for S. And there's our sample size of 20 being plugged in here. All right, so now that we've plugged into the thing, we should name what we're actually doing. But what are we actually doing? Well, we only took one sample. Yeah, we had 20 data points, but we only took one sample. So this is a one sample T interval. All right. So one sample T interval. You don't even have to say that it's for means, but it is for means. Let's go ahead and run this thing. So stat arrow over to test, and we're going to drop down to t-test. Now we actually have data this time, so we're going to highlight the word data. And our mean, well, they claimed it was going to be 12 ounces, so we need to fill that in. Our list is an L1. If yours doesn't say that, press the blue button followed by the number 1. And we were concerned about it being, oh, excuse me, we're not doing a stat test t-test. Stat test number 8 is t-interval. That's what we're interested in. And the list is L1, and we want to do a 95% interval. And we find out 11.81 to 11.97. So this is my lower bound, 11.81, and this is my upper bound. Now this is concerning because 12 ounces is supposed to be 12 ounces and it doesn't lie in there. So it does look like Mr. Spencer's not getting his happy juice, so he's probably not very happy. Anyway, our parameter, let mu equal the true population mean amount of happy juice in the cans. All right, so here we go. Easy enough. That's our parameter. That's what we're interested in. Conditions, well, random sample, and when we look back, they told us it was a random sample, and we know it was a random sample of size 20. The next thing we need to do is check the n is less than a 10%. And if I go 20 times 10, that equals 200. And that's less than the 1,000 because we always need to make the comparison. So this needs to be less than 1,000. All right. So n is less than 10% of the population. Finally, we need to check normality. Well, in this case, our sample size of 20 is not greater than 30. So we can't say normal by central limit theorem. But fortunately, up here, they said that it was normally distributed. So that was given to us. So we can just check that off. All right. So all 3 conditions have been checked. It's a random sample. The sample size 20 times 10 is 200 is less than 1,000. So our n is less than 10% of the population. And they told us it was normal. So what are we? Well, we are 95% confident that the true population mean amount of happy juice, this is just a restatement of our parameter right here, lies within the interval. Well, here's our interval that we calculated earlier, and the same thing as we have up there. Lastly, the meaning. In repeated sampling, we expect this method to capture the true population mean amount of happy juice in cans 95% of the time. Once again, this is just a restatement of the parameter. All right. Thank you for watching. I hope this helped. Look forward to seeing you on the next one. Thank you.